Hello there. Tonight, you are about to drift into something far greater than noise, far deeper than thought. A place where time slows, where silence stretches endlessly, and where the vast machinery of the universe moves with a calm, unstoppable precision. The solar system, not as you were taught, not as a list of planets, but as a living, breathing rhythm of motion shaped by gravity, guided by light, and held together by a quiet force that never speaks, yet never fails. Out there, worlds are turning right now. Storms are forming. Ice is drifting. Distant moons are circling their giants in perfect obedience, and the sun continues to burn, steady, patient, eternal. Nothing rushes. Nothing hesitates. Everything moves exactly as it should. And as you listen, you become part of that rhythm. Your breath slows. Your thoughts soften. Your mind begins to drift, not into sleep, but into understanding. A deeper awareness of just how vast and how calm this universe truly is. So stay with me. Let the darkness settle gently around you. Let the silence guide you. And if you find yourself drawn into this stillness, if this journey begins to quiet your mind and ease your thoughts, then, in your own time, consider subscribing to the channel. And if this moment brings you even a small sense of calm, a quiet release from the noise of the day, you can show your support by liking the video. No rules, no pressure, just a simple, silent choice like everything else in the universe. Now, close your eyes if you wish, and let us begin. Chapter 1, The Quiet Birth of Our Solar System. Hello there. Tonight, we begin not with noise, but with silence. A silence so vast, so complete, that even time itself seemed to move more slowly within it. Long before the familiar glow of sun warmed the planets, before Earth had oceans, skies, or life, there was only a drifting cloud. This cloud, known as a nebula, was not empty. It was filled with tiny particles of dust, frozen gases, and the remnants of ancient stars that had lived and died long before our solar system ever existed. In fact, one of the quiet truths of our origins is this: everything here, every rock, every ocean, every breath is made from the ashes of stars that exploded billions of years ago. Somewhere within this vast cloud, something began to change. A gentle disturbance, perhaps the distant shock wave of a supernova, caused the cloud to slowly collapse under its own gravity. And gravity, though invisible and silent, is one of the most powerful sculptors in the universe. It does not rush. It does not force. It simply pulls steadily, patiently. As the cloud collapsed, it began to spin. Not quickly at first, just a slow, graceful rotation. But as it shrank, the spin increased, much like a figure skater pulling in their arms. Over time, the cloud flattened into a rotating disk, glowing faintly as particles collided and warmed. At the very center of this spinning disk, matter began to gather more densely. This was the beginning of the sun. At first, it was only a protostar, a growing sphere of gas, not yet shining with the brilliance we know today. But deep within its core, pressure and temperature were rising. Hydrogen atoms were being pushed closer and closer together, until eventually they fused. And when fusion began, the sun ignited. This moment, quiet yet powerful, marked the true birth of our solar system. Light spread outward, warming the surrounding disk, illuminating a scene that had once been hidden in darkness. Around the newborn sun, countless tiny particles continued to collide. Some stuck together, others broke apart. But over millions of years, these grains of dust grew into pebbles, pebbles into rocks, and rocks into massive bodies called planetesimals. This process, known as accretion, is another gentle truth of the universe. Even the largest worlds begin as something small. Within this swirling disk, regions closer to the sun became hotter. Here, only metals and rocky materials could survive. This is why the inner planets, like Mercury, Venus, Earth, and Mars, are made mostly of rock and metal. Farther out, where temperatures were colder, ices could form. Water, methane, ammonia, these frozen compounds gathered in abundance, helping to create the giant planets, like Jupiter and Saturn, which grew large enough to pull in vast atmospheres of gas. But the early solar system was not calm. It was a place of collisions of constant impacts. Young planets were struck by countless objects, reshaping their surfaces again and again. One of these impacts, long ago, likely led to the formation of Earth's moon, a companion that would go on to shape tides, stabilize our planet's tilt, and quietly influence life itself. Yet despite this chaos, there was a kind of order emerging. Each planet settled into its orbit, tracing a path around the sun that would remain stable for billions of years. These orbits are not random. They're the result of delicate gravitational balances, like a slow and endless dance. And here is a calming truth to hold on to. Once these orbits formed, they became remarkably stable. For over 4.5 billion years, the planets have continued their journey around the sun with quiet precision. Even now, as you listen, Earth is moving through space at about 30 kilometers per second, yet you feel none of it. There is no wind, no sensation of motion, only stillness. Another gentle truth is that the solar system is mostly empty. The distances between planets are so vast that if Earth were the size of a small marble, Jupiter would be hundreds of meters away. Space is not crowded. It is spacious, quiet, and calm. And yet, within that emptiness, everything is connected by gravity. Gravity holds the planets in orbit. It shapes their paths. It even influences the smallest particles drifting between them. Without gravity, the solar system would simply drift apart, slowly dissolving back into the darkness from which it came. But it does not. Instead, it remains bound together, a family of worlds, each with its own story, its own character, its own quiet rhythm. And perhaps one of the most comforting truths of all is this: the solar system is not chaotic now. It is stable, predictable, and deeply consistent. The sun rises, the planets orbit, the cycles continue. Even the light reaching your eyes right now from the sun above began its journey about 8 minutes ago. It traveled across millions of kilometers of space, uninterrupted, until it gently touched Earth. Everything here moves, but nothing feels rushed. As the early chaos faded, the solar system slowly cooled. Impacts became less frequent. Surfaces stabilized. Atmospheres formed. Oceans appeared. And in one small corner of this vast system, life began. But that story belongs to later. For now, imagine the stillness of that ancient disk, the slow gathering of dust, the quiet ignition of a star. A beginning that was not loud, not sudden, but patient. Because the universe does not hurry. It builds slowly, carefully, over unimaginable spans of time. And as you drift deeper into relaxation, you can picture it clearly. A dark, silent cloud, gently collapsing, spinning, glowing, until at last it becomes a system of worlds. A system that you are part of. A system that continues, even now, in perfect quiet motion. As the early solar system continued to settle, the chaos that once defined it began to soften into something far more graceful. The collisions became less frequent. The violent impacts that once shaped entire worlds slowly faded into rare events. What remained was a quiet system of motion, each object following its path around the sun with remarkable consistency. But even in this calm, there were still stories unfolding, subtle changes that would define the solar system we know today. One of the most fascinating truths is that planets did not always form exactly where they are now. In the early days, giant planets like Jupiter likely migrated through the disk of gas and dust. Imagine a massive world, many times larger than Earth, slowly drifting inward toward the sun, then shifting outward again. This movement, though incredibly slow, would have reshaped the entire solar system, scattering smaller objects, altering orbits, and influencing where other planets could form. This gentle migration may explain why Mars is smaller than expected, and why the asteroid belt exists as a scattered collection of rocky fragments instead of a fully formed planet. The asteroid belt itself is another quiet reminder of what could have been. Located between Mars and Jupiter, it contains countless rocky bodies, some tiny like pebbles, others hundreds of kilometers wide. These objects are ancient, unchanged remnants from the earliest days of the solar system. They're like time capsules, preserving the original materials that never quite came together to form a planet. And yet, despite their numbers, the asteroid belt is mostly empty space. If you were to travel through it, you would likely see very little, just distant rocks drifting silently in the darkness. Far beyond the asteroid belt, the outer regions of the solar system hold even more distant secrets. Here, icy bodies formed in the cold shadows, where sunlight was faint and temperatures were extremely low. These regions gave rise to objects like comets, frozen wanderers that occasionally journey toward the inner solar system, leaving glowing tails behind them. Comets are among the oldest objects we can observe. They are made of ice, dust, and organic compounds, materials that have remained largely unchanged for billions of years. When one passes close to the sun, it begins to warm, releasing gas and dust into space, creating a soft, luminous tail that always points away from the sun. This tail is not blown backward by motion, but gently pushed by solar radiation itself. Another calm truth is that time moves differently in space. Not because clocks change, but because processes unfold over such immense periods. What might seem like stillness is often motion so slow, so gradual, that it becomes almost invisible. For example, even now, the orbits of planets are subtly shifting. They were born from the same cloud, shaped by the same forces, and continue to move within the same cosmic structure. Even the light that travels through this system carries a story. When sunlight reflects off a planet or a moon, it becomes a messenger, bringing information across space. The light you see from Venus or Mars has traveled millions of kilometers, carrying with it subtle details about those distant worlds. And yet, despite all this motion, all this distance, the solar system feels calm. There's a rhythm to it, a quiet, predictable harmony that has endured for billions of years. As you rest and listen, imagine this vast system from above. The sun at the center, planets tracing gentle circles, distant comets drifting in long arcs, and beyond it all, the faint boundary where our solar system meets the stars. It is not chaotic anymore. It is balanced. It is steady. It is peaceful. And perhaps that is the final truth of this beginning. The solar system was not only born from chaos, it transformed into harmony. A harmony that continues right now, as you breathe, as you rest, as you drift. Chapter 2. The gentle fire of the sun. Before any planet could cool, before oceans could form, before even the faintest hint of life could exist, there was only light. At the center of our solar system burns the sun, a star so vast, so steady, that it quietly governs everything around it. And yet, despite its immense power, it does not roar or rush. It shines patiently, endlessly, like a slow heartbeat in the darkness. One of the most calming truths about the sun is that it is not fire in the way we understand it on Earth. There is no burning wood, no oxygen-feeding flames. Instead, deep within its core, something far more subtle is happening. Hydrogen atoms are being gently pressed together under extreme pressure until they fuse into helium. This process, known as nuclear fusion, is the true source of the sun's light and warmth. And at the heart of this process lies one of the most famous ideas in physics: E equals mc squared. This simple equation tells us that a tiny amount of mass can be converted into an enormous amount of energy. Inside the sun, every second, millions of tons of matter are quietly transformed into pure energy, radiating outward in all directions. And yet, from Earth it feels gentle. The sunlight that warms your skin began its journey in the sun's core, but it did not travel outward quickly. In fact, it can take thousands, even hundreds of thousands, of years for energy to move from the core to the surface. It bounces slowly, randomly, from particle to particle, like a whisper passing through a crowded room. Only when it reaches the surface does it finally escape, racing across space at the speed of light. It takes about 8 minutes for that light to reach Earth. 8 quiet minutes across millions of kilometers before it gently touches oceans, mountains, and everything in between. Another fascinating truth is the sheer size of the sun. It contains about 99.8% of all the mass in the solar system. Every planet, moon, asteroid, and comet combined makes up only a tiny fraction compared to this single star. If the sun were hollow, it could fit over 1 million Earths inside it. And yet, despite this immense size, it appears small in our sky. Just a bright disk, easy to overlook. This is the illusion of distance. The sun is about 150 million kilometers away, a distance so vast that even light takes time to cross it. And still, that light feels immediate, constant, reliable. But the sun is not completely unchanging. Its surface, known as the photosphere, is in constant motion. Hot plasma arises, cools, and sinks again in slow, rolling patterns called convection. These movements create a texture that looks almost like boiling, yet it unfolds over timescales that feel calm and steady. Occasionally, darker regions appear on the surface, sunspots. These are slightly cooler areas caused by intense magnetic activity. They may look small from Earth, but many sunspots are actually larger than entire planets. They drift slowly across the sun's surface, appearing and fading in cycles that last about 11 years. This cycle is another gentle rhythm of the solar system. Every 11 years, the sun's magnetic activity increases, leading to more sunspots, solar flares, and bursts of energy. Then, just as slowly, it quiets again. Even in its activity, the sun follows a pattern. And then there is the solar wind, a continuous stream of charged particles flowing outward from the sun in all directions. This wind travels across the solar system, shaping invisible boundaries and interacting with planets along the way. When it reaches Earth, it is mostly deflected by our magnetic field. But near the poles, some of these particles slip through, colliding with atoms in the atmosphere and creating the soft, glowing lights known as auroras. These shimmering curtains of green and red light are, in a way, a conversation between the sun and Earth, a quiet exchange of energy visible only in the darkest skies. Another calming truth is that the sun is remarkably stable. Stars can be violent. Some explode. Others pulse or vary dramatically in brightness. But the sun belongs to a class of stars known as main sequence stars, steady, long-lived, and reliable. It has been shining for about 4.6 billion years and will continue to shine for billions more. This stability is what makes life possible. If the sun's energy output varied wildly, Earth's climate would be unpredictable, perhaps even uninhabitable. But instead, the sun provides a consistent flow of energy, a steady foundation upon which everything else depends. Even the colors we see, the warmth we feel, are shaped by the sun. Its light contains a spectrum of wavelengths, from visible light to infrared and ultraviolet. When this light interacts with Earth's atmosphere, it scatters in ways that create blue skies, golden sunsets, and soft twilight hues. Every sunrise, every sunset, is a quiet reminder of the sun's presence. And yet, despite being so familiar, the sun is still full of mysteries. Its outer atmosphere, called the corona, is much hotter than its surface, reaching temperatures of millions of degrees. This seems counterintuitive, and scientists are still working to fully understand why. During a total solar eclipse, when the moon passes perfectly between Earth and the sun, the corona becomes visible, a faint, glowing halo surrounding the darkened disk. It is one of the most serene sights in the sky, a moment when the overwhelming brightness of the sun softens, revealing its delicate outer layers. Another quiet truth is that the sun is not alone in its journey. It orbits the center of the Milky Way galaxy, carrying the entire solar system with it. This journey takes about 225 million years to complete, an orbit so vast that it is difficult to truly imagine. And yet, as it moves, the sun continues to shine, unchanged in its purpose. It does not rush. It does not waver. It simply exists, radiating energy into the surrounding space. And as you listen, as you begin to feel heavier, more relaxed, you can imagine that steady glow. A star at the center of everything, holding the planets in place, guiding their motion, illuminating their paths. A gentle fire, not wild or chaotic, but calm, constant, and deeply reassuring. As the steady glow of the sun continues to radiate outward, there is a quiet truth that often goes unnoticed. The sun is not just a source of light. It is a keeper of time. Every orbit, every season, every gentle shift in warmth on Earth is guided by the sun's presence. Without it, time itself, at least as we experience it, would lose its rhythm. Days would not begin or end, seasons would not change, and the familiar cycles of life would fade into stillness. Yet the sun measures time not in seconds or hours, but in vast, silent phases of existence. Right now, the sun is in what astronomers call its main sequence stage, a long, stable period where it fuses hydrogen into helium at a steady rate. This stage will last for about 10 billion years in total, and we're nearly halfway through it, which means, in a calm and reassuring sense, the sun is still in its quiet middle age. Another gentle truth is that the sun is constantly losing mass. Not dramatically, not in a way we would notice, but slowly, steadily. Through the process of fusion and through the outward flow of the solar wind, tiny amounts of the sun's mass are converted into energy and carried away into space. Every second, about 4 million tons of matter vanish in this way. And yet, because the sun is so incredibly massive, this loss is almost insignificant. It continues to shine, unchanged in appearance, as if nothing has been lost at all. This quiet transformation, mass into energy, is one of the most subtle and beautiful processes in the universe. Another fascinating detail is that the sun does not rotate as a solid object. Unlike Earth, which spins as a single unit, the sun is made of plasma, a flowing, dynamic state of matter. Because of this, different parts of the sun rotate at different speeds. The equator completes a rotation in about 25 days, while regions near the poles can take over 30 days. This is known as differential rotation. It creates gentle twists and tangles in the sun's magnetic field, contributing to the cycles of solar activity we observe. Over time, these magnetic fields can become so complex that they suddenly release energy in the form of solar flares. Solar flares are brief bursts of radiation, bright, energetic flashes that travel across space. Though they sound intense, most of them pass by Earth without any noticeable effect, thanks to our planet's protective magnetic field. Still, they're a reminder that even the calmest stars have moments of quiet intensity. And then there are coronal mass ejections, vast clouds of charged particles released from the sun's outer atmosphere. These events can travel across the solar system, occasionally interacting with planets in subtle ways. When one reaches Earth, it can enhance the beauty of auroras, painting the skies with even more vivid colors. But again, this is not chaos. It is part of a rhythm, a cycle, a pattern that repeats over time. Another soothing truth is that the sun's energy supports nearly every process on Earth. It drives the weather, warms the oceans, fuels photosynthesis in plants, and even influences the movement of air across continents. Without the sun, Earth would quickly become a frozen, silent world. And yet, the energy we receive is only a tiny fraction of what the sun emits. Most of its light travels outward into space, never touching a planet, never being absorbed, simply continuing on into the vastness beyond. In this way, the sun is both generous and indifferent. It gives freely, but without intention, without awareness. It simply shines. Another calming perspective is to imagine the sun not as a distant object, but as something you're already connected to. The warmth you feel during the day, the light that fills a room, even the energy stored in the food you eat, all of it originates from the sun. It is a quiet, continuous presence in your life, even when you are not aware of it. And yet, despite its importance, the sun remains perfectly balanced. If it were slightly more massive, it might burn too quickly, becoming unstable. If it were slightly smaller, it might not produce enough energy to support life as we know it. Its size, its temperature, its stability, all seem almost precisely suited to create the conditions we experience. But this is not design. It is simply the result of natural processes unfolding over time. Another gentle truth is that the sun will not remain the same forever. Billions of years from now, it will begin to change. As hydrogen in its core becomes depleted, the sun will expand into a red giant, growing larger and cooler at the surface, while its core becomes hotter and denser. During this phase, it may expand far enough to engulf the inner planets, possibly even reaching the orbit of Earth. But this is not something to fear. It is a distant future, far beyond any human timescale. For now, the sun remains steady, constant, reliable. And perhaps that is the most comforting truth of all. In a universe that can seem vast and unpredictable, the sun provides a sense of continuity. It rises, it sets, it repeats, day after day, year after year. Even when clouds obscure it, even when night falls, it is still there, shining, waiting, continuing its quiet work. As you relax further, you can imagine the sun not as something harsh or blinding, but as something soft and distant. A glowing sphere suspended in darkness, radiating warmth into the silence. No sound, no urgency, just light moving outward, touching worlds, sustaining life, and then continuing on. And as that light travels, so does the story of the solar system itself. A story that began with a cloud, formed into a star, and continues now in steady, predictable motion. A gentle fire at the center of everything. Chapter 3. Mercury and Venus. Worlds of extremes. There is something quietly fascinating about the worlds closest to the sun. They exist in a region where light is strongest, where heat is most intense, and where time itself seems to move in slightly unfamiliar ways. These inner worlds, Mercury and Venus, are often described as extreme. But beneath that word lies a deeper truth. They are calm in their own way, steady in their patterns, and quietly consistent over billions of years. Let's begin with Mercury. Mercury is the smallest planet in the solar system and the closest to the sun. From a distance, it appears as a simple gray sphere, covered in craters, silent and still. There are no oceans, no clouds, no signs of life, only rock and shadow. And yet, Mercury holds some of the most surprising truths. One of the most striking is its relationship with time. A single day on Mercury, the time it takes to rotate once on its axis, is incredibly long. In fact, one full rotation takes about 59 Earth days. But its year, the time it takes to orbit the sun, is only 88 Earth days. This creates a strange rhythm. A day on Mercury is longer than its year. To understand this more clearly, consider how orbital motion defines a year. Without diving too deeply into the mathematics, this relationship shows that planets closer to the sun move faster in their orbits. Mercury, being so close, travels quickly, completing its orbit in just 88 days, while rotating much more slowly. This results in a unique experience of sunlight on its surface. If you could stand on Mercury protected from the heat, You would see the sun rise, pause, move backward briefly, and then continue across the sky. This unusual motion is caused by the interplay between Mercury's rotation and its rapid orbit. It is a slow, almost dreamlike cycle, unlike anything on Earth. Another quiet truth about Mercury is its temperature. Because it has almost no atmosphere, it cannot retain heat. During the day, temperatures can rise to about 430 degrees Celsius, hot enough to melt certain metals. But at night, when the sun disappears below the horizon, the heat escapes quickly and temperatures could drop to minus 180 degrees Celsius. This extreme contrast, burning heat and freezing cold, exists side by side in perfect stillness. There is no wind to carry warmth, no air to soften the transition. Only silence and temperature. Despite its proximity to the sun, Mercury is not the hottest planet. That title belongs to Venus. Venus, often called Earth's twin because of its similar size, is a world wrapped in thick clouds. From afar, it appears bright and beautiful, reflecting sunlight so effectively that it is one of the most visible objects in the night sky. But beneath those clouds lies a very different reality. Venus has an atmosphere composed mostly of carbon dioxide, with clouds of sulfuric acid. This dense atmosphere traps heat in a process known as the greenhouse effect, creating surface temperatures of around 470 degrees Celsius, hot enough to melt lead. And unlike Mercury, Venus does not cool down at night. Its thick atmosphere holds on to heat, distributing it evenly across the planet. Whether it is day or night, the temperature remains almost the same, consistently intense, yet strangely stable. Another fascinating truth is that Venus rotates in the opposite direction of most planets. This is called retrograde rotation. While Earth spins from west to east, Venus spins from east to west. As a result, if you were somehow standing on its surface, the sun would appear to rise in the west and set in the east. It is a quiet reversal, a subtle difference that makes Venus feel even more distant from the familiar rhythms of Earth. And like Mercury, Venus also has an unusual relationship with time. A single rotation of Venus takes about 243 Earth days, making its day longer than its year, which lasts about 225 Earth days. So once again, we find a world where time does not behave as expected. A day longer than a year, a slow turning beneath an unchanging sky. Another gentle truth is that Venus is incredibly still at the surface. High above, in its thick clouds, winds can move at incredible speeds, circling the planet in just a few days. But near the surface, the dense atmosphere slows everything down. The air is heavy, almost motionless. It creates a kind of quiet pressure, a stillness that feels almost complete. Even sound would behave differently there, traveling more slowly through the dense air. And then there is the sky itself. Because of the thick cloud cover, sunlight does not reach the surface directly. Instead, it is scattered and diffused, creating a soft, orange glow. There are no clear shadows, no sharp contrasts, only a uniform brightness. It is a world without clear edges, a place where light exists, but never quite reveals the sky. Another fascinating connection between Mercury and Venus is their lack of moons. Unlike Earth or Mars, these inner planets do not have natural satellites. They move alone, orbiting the sun without companions. This solitude adds to their quiet nature. No tidal interactions, no reflected light from nearby moons, just the steady presence of the sun. And yet, despite their differences, both Mercury and Venus share a common origin. They form from the same disk of material shaped by the same processes billions of years ago. Their paths diverged over time, influenced by distance, atmosphere, and countless subtle factors. But at their core, they remain part of the same story. Two worlds close to the sun, each revealing a different side of what a planet can be. One bare and exposed, silent and extreme. The other hidden and dense, warm and unchanging. And as you continue to relax, you can imagine them both orbiting quietly, tracing their paths around the sun, untouched by time in the way we understand it. No rus, no noise, just motion and stillness existing together. As these two inner worlds continue their quiet journey around the sun, their differences become even more fascinating the closer you imagine them. Mercury and Venus may share a similar origin, but time, distance, and subtle variations have shaped them into completely different environments, each calm in its own way, each extreme in its own silence. Let us return for a moment to Mercury. Its surface is ancient, one of the oldest in the solar system. Covered in craters formed by countless impacts billions of years ago, Mercury has remained largely unchanged. There is no atmosphere to erode these marks, no wind, no rain, no flowing water to reshape the land. Every crater is a memory, preserved in stillness. Some of these craters are enormous, stretching hundreds of kilometers across. One of the largest, known as the Caloris Basin, was formed by a massive impact early in Mercury's history. The energy released would have reshaped the planet's surface, sending shockwaves through its interior. And yet, after all that, silence returned. Another quiet truth is that Mercury is slowly shrinking. Over time, as its interior cools, the planet contracts slightly. This causes the surface to wrinkle, forming long cliffs called scarps. These cliffs can stretch for hundreds of kilometers, rising gently from the otherwise smooth terrain. It is a slow, almost imperceptible change. A planet quietly folding in on itself over billions of years. Mercury also has a surprisingly large core. In fact, its metallic core makes up a significant portion of the planet's volume. This dense core generates a weak magnetic field, much smaller than Earth's, but still present. It is a subtle reminder that even small, quiet worlds can hold hidden complexity beneath their surfaces. And perhaps one of the most surprising truths is this. Despite being so close to the sun, Mercury contains ice. In permanently shadowed craters near its poles, temperatures remain low enough for water ice to exist. These regions never receive direct sunlight, allowing frozen material to remain stable for billions of years. So even on a world of extremes, there are pockets of quiet preservation. Now, let your thoughts drift gently toward Venus. Unlike Mercury's exposed surface, Venus is completely hidden beneath its thick atmosphere. No visible light can penetrate its clouds to reveal the ground below. Everything we know about its surface comes from radar mapping and spacecraft observations. And what those observations reveal is both dramatic and strangely serene. The surface of Venus is dominated by vast volcanic plains. There are thousands of volcanoes scattered across the planet, far more than on Earth. Some are large, shield-like structures, while others are smaller and more widespread. Evidence suggests that Venus may still be volcanically active, though its eruptions would be slow and heavy, shaped by the dense atmosphere. Another gentle truth is that Venus has no plate tectonics like Earth. Its surface does not shift in large, moving plates. Instead, heat builds up beneath the crust over time, until it is released in large-scale resurfacing events. These events may have occurred in the distant past, covering much of the planet in fresh volcanic rock. As a result, the surface of Venus is relatively young, geologically speaking. But again, this change happens over immense timescales. Nothing sudden, nothing rushed, just slow transformation. Another fascinating aspect of Venus is its pressure. At the surface, the atmospheric pressure is about 90 times greater than that of Earth, equivalent to being nearly a kilometer underwater. This immense pressure, combined with the heat, creates an environment where metals can soften and where spacecraft can survive only for a short time. And yet, within that pressure, there is stillness. The dense air moves slowly, sound travels differently, and everything feels heavy, grounded, quiet. Another calming truth is that both Mercury and Venus lack the kind of protective magnetic field that Earth has. This means they're more exposed to the solar wind, the stream of particles flowing outward from the sun. Over time, this exposure has had significant effects, especially on Venus. Scientists believe that Venus may once have had water, perhaps even oceans. But without a strong magnetic field to protect its atmosphere, much of that water was lost to space, broken apart by solar radiation, and carried away. What remains is a dry, hot world wrapped in clouds. A reminder of how delicate planetary balance can be. And yet, even in this loss, there is no chaos, only change. Another quiet truth is that both Mercury and Venus can be seen from Earth. Mercury is often difficult to spot, appearing briefly near the horizon just before sunrise or after sunset. It never strays far from the sun in the sky, making it a fleeting presence. Venus, on the other hand, is brilliant. It is often called the morning star or the evening star, depending on when it appears. Its brightness comes from its thick clouds, which reflect sunlight efficiently. To ancient observers, Venus was a symbol of beauty. But now we understand that beneath that brightness lies a world of intense heat and pressure, a contrast that feels almost poetic. Another gentle connection between these two planets is their silence. Neither Mercury nor Venus has the kind of weather we experience on Earth. There are no rainstorms, no flowing rivers, no rustling leaves. Mercury is silent because it has no atmosphere. Venus is silent because its atmosphere is too dense, too heavy, muting movement and sound. Two different paths leading to the same stillness. And as you rest, you can imagine these worlds in motion. Mercury, small and swift, tracing its tight orbit close to the sun, its surface shifting from intense light to deep shadow. Venus, wrapped in clouds, turning slowly, its surface hidden, its heat constant, its sky glowing softly with filtered light. Both moving in perfect rhythm, both part of the same system, both shaped by time, yet untouched by the kind of change we know on Earth. And perhaps that is the most soothing truth of all. Even in extremes, there is balance. Even in the harshest conditions, there is calm. Because the universe does not rush, it does not force. It simply allows things to be exactly as they are. Chapter 4: Earth and the Moon. A cosmic partnership. There is a quiet uniqueness to Earth. Among all the worlds that circle the sun, Earth is the only one we know where oceans breathe, clouds drift, and life gently unfolds in countless forms. But Earth is not alone in its journey. It moves through space with a constant companion, the Moon, and together they form one of the most delicate and balanced partnerships in the solar system. To understand this partnership, we must go back to a time when Earth was very different. In its earliest days, Earth was a molten world. Its surface was covered in flowing rock, its atmosphere thick with volcanic gases, its environment far too intense for anything familiar. And then, in a moment that would shape everything that followed, something extraordinary happened. A Mars-sized body, often referred to as Theia, collided with the young Earth. The impact was immense, yet it was not destructive in the way we might imagine. Instead of shattering the planet, it reshaped it. Debris from both Earth and the impacting body was thrown into orbit, forming a glowing ring of material around the planet. Over time, this debris began to gather. Slowly, gently, it came together to form the Moon. This origin story reveals one of the most profound truths. The Moon is, in part, made of Earth itself. It is not a captured object, not a distant visitor, but a companion born from the same event that helped shape our planet. And from that moment on, Earth and the Moon have been connected in ways that are both visible and subtle. One of the most calming influences of the Moon is its effect on Earth's rotation. The gravitational pull between Earth and the Moon creates tides in the oceans, slow, rhythmic rises and falls of water that occur twice each day. These tides are not sudden, not forceful, but gentle, predictable movements that follow the Moon's position in the sky. Even now, as you rest, the oceans are shifting. Water is being drawn toward the Moon, then released, then drawn again. A quiet rhythm, repeating endlessly. But the Moon's influence goes deeper than tides. It also stabilizes Earth's tilt. Earth is tilted at an angle of about 23.5 degrees relative to its orbit around the Sun. This tilt is what creates the seasons, gradual changes in sunlight that bring warmth, cold, growth, and rest. Without the Moon, this tilt might vary wildly over time. Earth could shift between extreme angles, causing unpredictable climate changes. But the Moon's steady gravitational presence helps keep this tilt stable, allowing seasons to remain gentle and consistent. Another soothing truth is that the Moon is slowly moving away from Earth. Each year, it drifts about 3.8 centimeters farther away. This movement is incredibly slow, almost imperceptible, but it has been happening for billions of years. In the distant past, the Moon appeared larger in the sky, and tides were stronger. Over time, as the Moon has moved outward, Earth's rotation has also slowed slightly, lengthening our days. This means that long ago, a day on Earth was shorter than it is now. Time itself, shaped by the presence of the Moon. And yet, even as the Moon drifts away, the connection remains. Another fascinating truth is the way the Moon shows only one face to Earth. This is called tidal locking. The Moon rotates on its axis at the same rate that it orbits Earth, which means the same side always faces us. The far side, the side we never see, remained hidden from human view until spacecraft revealed it. This creates a sense of familiarity. When you look at the Moon, you're always seeing the same patterns, the same dark plains and bright highlands. It becomes a constant presence in the sky, unchanging, reliable. And those dark regions, often called seas or maria, are not water at all. They are vast plains of solidified lava, formed billions of years ago when volcanic activity filled large impact basins. Over time, these plains cooled and darkened, creating the patterns we recognize today. Another gentle truth is that the moon has no atmosphere. Because of this, its surface remains unchanged by weather. Footprints left by astronauts during missions like Apollo 11 moon landing are still there, preserved in the dust. There is no wind to erase them, no rain to wash them away, only stillness. And in that stillness, time seems to pause. Back on Earth, however, the presence of the moon has helped create conditions where life could thrive. The tides it generates may have played a role in the early development of life, creating environments where water moved between land and sea, mixing nutrients, encouraging chemical interactions. Even today, tides influence ecosystems, shaping the behavior of countless species. Another common truth is the way sunlight and moonlight interact. During the day, the sun dominates the sky, filling it with brightness. But at night, the moon reflects sunlight back to Earth, creating a softer, cooler glow. This reflected light is gentle, diffused, perfect for quiet moments. It does not overwhelm. It simply illuminates. And as the moon moves through its phases, new, crescent, quarter, full, and back again, it creates a cycle that repeats every month. A steady rhythm, marking the passage of time. Another fascinating detail is that Earth itself is not perfectly still. It rotates once every 24 hours, creating the cycle of day and night. But it also orbits the sun once every year, following a path that is nearly circular. This motion, though incredibly fast, feels completely calm. At the equator, Earth spins at about 1,670 kilometers per hour, and yet you feel none of it. No wind, no motion, only stillness. This is one of the quiet wonders of the solar system. Everything is moving, yet everything feels at rest. And within this motion, Earth and the moon continue their partnership. A planet and its companion, bound by gravity, shaping each other's behavior, moving together through space. Not as separate objects, but as a connected system. And as you relax further, you can imagine them together. Earth blue and vibrant, oceans slowly shifting, clouds drifting across continents. The moon, pale and steady, reflecting light, guiding tides, marking time. Two worlds moving in harmony. As Earth continues its quiet journey around the sun, its connection with the moon reveals even deeper layers of calm, balance, and quiet influence. There's a gentle precision to the way these two worlds move together. The moon orbits Earth at an average distance of about 384,000 kilometers. This distance is not random. It is part of a stable gravitational relationship that has endured for billions of years. The pull between Earth and the moon creates a system where both bodies actually orbit a shared center of mass, a point located within Earth, but not exactly at its center. This means Earth itself performs a subtle motion, a slow, almost imperceptible wobble as the moon circles it. A quiet dance, repeated endlessly. Another calming truth is the way eclipses occur within this partnership. Sometimes the alignment between the sun Earth and the moon become so precise that shadows fall across space in perfect geometry. When a moon passes between Earth and the sun, it creates a solar eclipse, briefly dimming the sunlight and casting a moving shadow across Earth's surface. And when Earth moves between the sun and the moon, a lunar eclipse occurs, where Earth's shadow gently darkens the moon. During a total lunar eclipse, the moon often takes on a soft, reddish glow. This happens because Earth's atmosphere bends and filters sunlight, allowing only longer wavelengths, reds and oranges, to reach the moon. It is a quiet transformation, subtle and beautiful. Another fascinating detail is how perfectly the sizes of the sun and the moon appear from Earth. Though the sun is vastly larger than the moon, it is also much farther away. This creates a remarkable coincidence. Both appear nearly the same size in the sky. Because of this, during a total solar eclipse, the moon can cover the sun almost exactly, revealing the delicate corona around it. This alignment is temporary on cosmic timescales. As the moon slowly drifts farther away from Earth, future eclipses will no longer look the same. But for now, we exist in a time where this balance creates one of the most serene sights in the universe. Another gentle truth is the role of the moon in shaping Earth's oceans. The tides we experience are not uniform. They vary depending on the positions of the moon and the sun. When the sun and moon align during full and new moons, their combined gravitational pull creates stronger tides, known as spring tides. When they are at right angles during quarter phases, the tides are weaker, called neap tides. These patterns repeat, quietly, predictably, guiding the movement of water across the planet. Even coastal landscapes are shaped by this rhythm. Shorelines change, sediments shift, ecosystems adapt, all under the steady influence of the moon. Another calming truth is that Earth's atmosphere protects and enhances this partnership. Unlike the moon, Earth has a thick atmosphere that scatters light, creates weather, and softens the extremes of temperature. This atmosphere allows us to see the moon in different ways, sometimes bright and sharp, sometimes diffused through clouds, sometimes glowing softly through haze. It creates variation without disrupting the underlying stability. And then there is the phenomenon of moonlight itself. Moonlight is not its own light. It is sunlight reflected from the moon's surface. But because the moon's surface is not highly reflective, the light it sends back is soft, muted, calming. It creates shadows that are gentle, outlines that are subtle, a world that feels quieter under its glow. Another fascinating aspect of this partnership is how it has influenced human understanding of time. For thousands of years, people have used the phases of the moon to measure months. The regular cycle, from new moon to full moon and back again, provided one of the earliest natural calendars. Even today, the word month is derived from a moon, a quiet reminder of how deeply this celestial companion has shaped human perception. Another truth, often overlooked, is that Earth and the moon are part of a larger gravitational network. While they are closely bound to each other, they're also influenced by the sun and, to a much smaller extent, by other planets. These interactions create subtle variations in their orbits, tiny changes that accumulate over long periods. Yet despite these influences, the system remains stable, balanced, predictable. Another calming realization is that the moon acts as a kind of shield. While not a barrier in the traditional sense, its presence has likely reduced the number of large impacts on Earth over time. Some objects that might have collided with Earth instead struck the moon, leaving behind the craters we see today. In this way, the moon has quietly absorbed part of the solar system's early chaos, helping to create a more stable environment for Earth. And then there is the simple, enduring presence of the moon in the night sky. No matter where you are on Earth, the moon rises and sets, following its path across the sky. It changes shape, shifts position, but always returns. A constant in a world that often feels anything but. As you relax deeper, imagine this partnership from a distance. Earth turning slowly blue and white, wrapped in clouds, oceans gently moving with a pull of gravity. And beside it, the moon, pale and steady, reflecting light, guiding tides, marking the passage of time. Together, they move through space, orbiting the sun, held in place by invisible forces that never waver. There is no noise in this movement, no urgency, only rhythm, only balance. And perhaps that is the most soothing truth of all. In a universe filled with vast distances and quiet motion, there exist connections that endure, partnerships that remain steady, even as everything else changes. Earth and the moon, moving together endlessly in calm, silent harmony. Chapter 5, Mars, the Silent Red Desert. There's a quiet loneliness to Mars. Not an emptiness that feels cold or distant, but a calm, open stillness like a desert stretching endlessly beneath a soft sky. Mars is often called the Red Planet, its surface colored by iron-rich dust that has slowly oxidized over billions of years. Rust spread gently across an entire world. And yet, beneath that red surface lies a story far more complex, one that whispers of change, of water, and of a past that may have been very different from what we see today. Mars orbits the sun at a greater distance than Earth, receiving less sunlight and less warmth. Because of this, its environment is cooler, quieter, more subdued. The average temperature on Mars is around minus 60 degrees Celsius, though it can vary depending on location and season. But like all planets, Mars moves in a steady rhythm. Its year lasts about 687 Earth days, nearly twice as long as a year on Earth. And its day, known as a sol, is remarkably similar to ours, lasting about 24 hours and 37 minutes. This similarity gives Mars a strangely familiar sense of time. Day follows night, seasons shift, and yet everything unfolds more slowly, more quietly. Another gentle truth is that Mars has seasons, much like Earth. Its axis is tilted at about 25 degrees, which means sunlight reaches different parts of the planet at different times of the year. As a result, Mars experiences spring, summer, autumn, and winter, though each season lasts longer due to its extended orbit. In the winter, carbon dioxide from the atmosphere can freeze at the poles, forming seasonal ice caps that grow and shrink with time. This slow transformation of the poles is one of the most subtle movements on the planet. A quiet breathing in and out across the Martian year. One of the most fascinating aspects of Mars is its landscape. It is home to some of the largest geological features in the entire solar system. Among them is Olympus Mons, a volcano so vast that it rises about 22 kilometers above the surrounding plains. That is nearly 3 times the height of Mount Everest. And yet, despite its size, Olympus Mons is not steep. Its slopes are gentle, spreading outward over hundreds of kilometers. It is a shield volcano formed by slow, flowing lava that built up over time. There is no urgency in its formation, only patience. Nearby, another immense feature stretches across the surface, Valles Marineris. This vast canyon system is over 4,000 kilometers long, so large that it would span the entire width of the United States if placed on Earth. Its depth reaches up to 7 kilometers in places, revealing layers of rock that hold clues to the planet's history. These features tell a story of a world that was once far more active. Volcanoes erupted, surfaces shifted, and water may have flowed. Yes, water. One of the most compelling truths about Mars is that it likely once had liquid water on its surface. Evidence from orbiters and rovers shows signs of ancient riverbeds, lake basins, and minerals that form in the presence of water. These features suggest that, long ago, Mars may have been warmer with a thicker atmosphere capable of supporting flowing water, perhaps even oceans. But over time, something changed. Mars lost much of its atmosphere. Without a strong magnetic field to protect it, solar wind gradually stripped away the gases that once surrounded the planet. As the atmosphere thinned, temperatures dropped and water either froze or evaporated into space. What remains today is a dry, cold world. But traces of that ancient water still exist. Frozen water ice lies beneath the surface and at the poles, waiting quietly. Another gentle truth is the nature of the Martian sky. Because its atmosphere is thin and filled with fine dust, the sky on Mars appears butterscotch or pink during the day. At sunset, however, something unusual happens. The sky near the sun turns blue. This reversal of colors creates a soft, almost dreamlike transition between day and night. Dust plays an important role on Mars. Fine particles cover much of the surface, and they can be lifted into the air by winds. Sometimes, these winds grow into vast dust storms that can cover the entire planet, lasting for weeks or even months. And yet, even these storms are not violent in the way we might imagine. The thin atmosphere means the winds carry less force than on Earth. The storms are more like slow-moving veils, gently shifting across the landscape. Another calming truth is the presence of two small moons orbiting Mars. Phobos and Deimos are irregularly shaped, likely captured asteroids. They are small, quiet, and move swiftly across the Martian sky. Phobos, the larger of the two, orbits very close to Mars and rises and sets multiple times in a single day. It appears larger in the sky than Earth's moon, but its shape is uneven, more like a drifting rock than a smooth sphere. These storms can grow so large that they envelop the entire planet, dimming sunlight and altering temperatures temporarily. But even at their peak, they move slowly like a planet wrapped in a shifting reddish haze. And when the storms settle, silence returns. Perhaps one of the most soothing truths about Mars is this. It is a world of preservation. Without active plate tectonics or heavy erosion, its surface features remain intact for incredibly long periods. Ancient valleys, volcanic plains, impact craters, all remain visible like a record of time written in stone. Nothing is rushed. Nothing is erased quickly. Everything lingers. And as you imagine Mars, you can see it clearly. A vast red desert stretching beyond the horizon under a soft, dusty sky. Volcanoes rising gently, canyons carved deep into the surface, ice resting quietly at the poles. a world that once may have been different, but now exists in calm stillness. As Mars continues its quiet orbit around the Sun, its stillness begins to feel less like emptiness and more like preservation. Mars is not a dead world in the way we often imagine. It is a world where change happens slowly, where time stretches out, and where the past remains visible, almost untouched. One of the most fascinating truths about Mars is how clearly it holds onto its history. On Earth, landscapes are constantly reshaped by wind, water, and tectonic activity. Mountains rise and erode. Oceans shift, forests grow and disappear. But on Mars, these processes are far less active. As a result, features that formed billions of years ago still remain. Ancient river channels can still be traced across the surface, winding paths that once carried flowing water. Dried lake beds lie undisturbed, their outlines preserved in the dust. Even the impact craters, formed by collisions long ago, remain sharp and defined. It is as if Mars remembers everything. Another gentle truth is the presence of subsurface ice. Though the surface appears dry, large amounts of water ice exist just beneath the soil. In some regions, this ice is mixed with dust, forming layers that can extend deep underground. At the poles, vast caps of water ice and frozen carbon dioxide expand and contract with the seasons. These frozen reservoirs are silent, stable, and enduring. They hint at a time when water may have been more abundant on the surface, a time when Mars might have looked very different. Another fascinating aspect is the thinness of the Martian atmosphere. Compared to Earth, Mars has less than 1% of the atmospheric pressure. This means the air is incredibly light, almost non-existent by our standards. Because of this, liquid water cannot remain stable on the surface for long. It either freezes or evaporates quickly. And yet, this thin atmosphere creates its own kind of calm. The sky is quiet, the winds are gentle, and sound would travel differently, faint and distant. Even dust, when it rises, does so slowly, drifting rather than rushing. Another soothing truth is the way light behaves on Mars. Sunlight is dimmer there than on Earth, softened by distance and filtered through the dusty atmosphere. Shadows are less sharp, colors more muted, creating a landscape that feels subdued and peaceful. At sunrise and sunset, the sky takes on subtle variations, soft oranges, pinks, and even hints of blue near the sun. A quiet palette, shifting slowly with time. Mars is also home to one of the most intriguing geological features, recurring slope lineae. These are dark streaks that appear seasonally on slopes, especially during warmer periods. For a time, scientists wondered if they might be caused by flowing liquid water. More recent evidence suggests they're likely linked to dry flows of sand or dust, possibly triggered by temperature changes. Even so, they remain a reminder that Mars is not entirely static. There's still small changes, subtle movements, quiet processes continuing beneath the surface. Another calming truth is the way Mars interacts with sunlight. Because of its distance from the Sun, it receives less energy than Earth. This reduced energy shapes everything, from temperature to atmospheric behavior to the potential for life. And yet, despite this lower energy input, Mars still follows the same fundamental rhythms as other planets. It rotates, it orbits, it experiences seasons. It participates in the same cosmic dance. Another fascinating detail is the presence of dust devils on Mars. These are small, swirling columns of air that lift dust from the surface, creating thin, twisting shapes that move across the landscape. They're similar to those on Earth, but often larger and more visible due to the fine dust. And yet, even these are not violent. They move quietly, slowly, leaving faint tracks behind them that can last for months. A temporary disturbance followed by stillness. Another gentle truth is the exploration of Mars by human-made machines. Rovers such as Curiosity rover and Perseverance rover have traveled across its surface, studying rocks, analyzing soil, and searching for signs of ancient life. These machines move slowly, carefully, navigating the terrain with patience. They do not rush. They observe, they record, they explore. And through them, we gain a deeper understanding of this quiet world. Another fascinating aspect is the possibility that Mars once had conditions suitable for life. Not necessarily complex life, but perhaps simple microbial forms. The presence of water, combined with the right chemical conditions, may have created environments where life could begin. If this is true, then Mars holds one of the most profound stories in the solar system, a story of potential life that rose and then faded. And yet, even if life once existed there, Mars now remains still. A place where time moves slowly, where change is subtle, where silence dominates. Another calming truth is the future of Mars. Unlike Earth, Mars is unlikely to undergo dramatic changes in the near future. Its atmosphere is thin, its geological activity minimal, and its environment stable in its own quiet way. It will continue to orbit the Sun, unchanged for millions, perhaps billions of years. A steady presence in a system of motion. And as you imagine Mars now, let the details settle gently in your mind. A red horizon stretching endlessly, dust drifting softly across the surface, ancient riverbeds tracing patterns through the land, ice resting quietly beneath the soil. Two small moons, Phobos and Deimos, moving across the sky, silent companions in a quiet orbit. No noise, no urgency, just a world that has settled into stillness, holding on to its past, moving gently through space. And perhaps that is the most peaceful truth of Mars. It is not empty. It is simply quiet. Chapter 6, The Giant Majesty of Jupiter. There is a quiet grandeur to Jupiter. It does not whisper in the way smaller worlds do, yet it does not roar either. It exists with a kind of steady dominance, a presence so vast that everything around it subtly adjusts in response. Jupiter is not just another planet. It is a world that shapes the very structure of the solar system. And yet, despite its immense size and influence, there is a calm rhythm to it. Jupiter orbits the Sun at a distance far greater than the inner planets. Here, sunlight is softer, more distant, casting a gentle glow across a world made not of solid ground, but of gas and storm. One of the most fascinating truths about Jupiter is that it has no solid surface in the way we understand it. If you could descend into its atmosphere, you would not find land or ocean waiting below. Instead, you would pass through layers of clouds deeper and deeper, where pressure increases gradually. The transition from atmosphere to interior is smooth, not sudden. A continuous descent without a clear boundary. Jupiter is composed mostly of hydrogen and helium, the same elements that make up the Sun. In fact, Jupiter contains more than twice the mass of all the other planets combined, and yet it is still far too small to ignite as a star. It remains a planet, a giant one, but a planet nonetheless. Another gentle truth is the speed at which Jupiter rotates. Despite its enormous size, Jupiter spins incredibly fast, completing one full rotation in just under 10 hours. This rapid rotation causes the planet to bulge at the equator, giving it a slightly flattened shape. But more importantly, it shapes the patterns we see in its atmosphere. The clouds of Jupiter are arranged in bands, alternating light and dark stripes that wrap around the planet. These bands are created by powerful jet streams, flowing in opposite directions at different latitudes. And yet, even these powerful winds follow a kind of order. They move continuously, predictably, forming patterns that have persisted for centuries. Perhaps the most iconic feature of Jupiter is the Great Red Spot. This Vishal storm has been observed for over 300 years, a swirling system larger than Earth itself. It is a high-pressure region, rotating slowly, with winds reaching incredible speeds. And yet, despite its scale, the Great Red Spot does not feel chaotic. It turns steadily, endlessly, like a slow-moving whirlpool in the sky. Another calming truth is that Jupiter emits more energy than it receives from the Sun. Deep within its interior, the planet generates heat, left over from its formation and from the slow compression of its immense mass. This internal heat rises through the atmosphere, contributing to the cloud patterns and storms we observe. It is a quiet warmth originating from within. Another fascinating detail is the composition of Jupiter's clouds. They are made of different chemicals, including ammonia crystals, ammonium hydrosulfide, and water. Each layer forms at a different altitude, creating a complex structure of clouds that vary in color and texture. The lighter zones and darker belts are not random. They're part of a system of rising and sinking gases, creating a dynamic yet stable pattern, a balance between motion and structure. Jupiter also has an incredibly strong magnetic field. It is the most powerful of any planet in the solar system, far stronger than Earth's. This magnetic field creates a vast region around the planet, known as the magnetosphere, which extends millions of kilometers into space. Within this region, charged particles are trapped, moving along invisible lines of force. And when these particles interact with Jupiter's atmosphere, they create auroras, much like those on Earth, but far more intense. These auroras glow near the poles, constant and steady, powered not only by the solar wind, but also by Jupiter's own rotation and internal energy. Another gentle truth is the number of moons that orbit Jupiter. It has dozens, over 90 known moons, each with its own story. Among them are the four largest, known as the Galilean moons: Io, Europa, Ganymede, and Callisto. These moons are not small, insignificant objects. Ganymede, for example, is larger than the planet Mercury. Europa is covered in ice, beneath which may lie a vast ocean. Io is the most volcanically active body in the solar system. Each one adds depth to Jupiter's quiet majesty. Another fascinating aspect is Jupiter's role as a protector. Because of its immense gravity, Jupiter can influence the paths of comets and asteroids, sometimes capturing them, sometimes deflecting them away from the inner solar system. In this way, Jupiter acts as a kind of shield, reducing the number of impacts that might otherwise reach planets like Earth. It does not do this intentionally. It simply exists, and its gravity shapes the paths of objects around it. Another calming truth is the way Jupiter moves through space. Despite its size and complexity, it follows a simple orbit around the Sun, taking about 12 Earth years to complete one journey. This orbit is smooth, stable, and predictable. Like everything in the solar system, Jupiter is part of a larger rhythm. And perhaps one of the most soothing realizations is this. Even the largest planet, even a world of storms and immense energy, exists in balance. Its winds, though powerful, are organized. Its storms, though vast, are steady. Its motion, though fast, feels calm. As you relax further, imagine Jupiter from a distance. A vishal sphere of swirling clouds, bands of color stretching across its surface, the great red spot turning slowly like a timeless storm. Moons orbiting around it, each tracing its own path, held in place by gravity. All of it moving together in quiet harmony. As Jupiter continues its slow and steady path around the Sun, its immense presence reveals even deeper layers of quiet complexity. Though it appears from afar as a swirling giant of clouds, Jupiter is also a system in itself, a miniature solar system of moons, rings, magnetic forces, and subtle interactions, all moving together in a calm and continuous flow. One of the most fascinating truths about Jupiter is what lies beneath its clouds. As you imagine descending into its atmosphere, the pressure would gradually increase, the temperature rising as you move deeper. The familiar clouds would give way to thicker layers of gas, until eventually the hydrogen itself begins to change. Under immense pressure, hydrogen transforms into a metallic state. This is not metal in the way we think of iron or steel, but a form of hydrogen where electrons move freely, allowing it to conduct electricity. This layer of metallic hydrogen is believed to surround Jupiter's core and plays a crucial role in generating its powerful magnetic field. It is a quiet transformation, invisible from the outside, yet essential to the planet's behavior. At the very center, there may be a dense core composed of heavier elements, rock and ice compressed under enormous pressure. Scientists are still studying this region, as it remains hidden beneath thousands of kilometers of gas. And yet, even without seeing it directly, we understand that it contributes to the balance of the entire planet. Another gentle truth is Jupiter's faint ring system. Unlike the bright, prominent rings of Saturn, Jupiter's rings are thin and subtle, composed mostly of tiny dust particles. They are difficult to see, requiring careful observation and specific lighting conditions. These rings were formed from debris, material ejected from small moons by impacts. They drift quietly around the planet, almost invisible, yet still part of its structure. Another fascinating aspect of Jupiter is its immense gravity. It is so strong that it shapes the motion of objects far beyond its immediate surroundings. Asteroids, comets, and even other planets feel its influence. This gravitational reach extends across vast distances, guiding trajectories in subtle ways. And yet, this force is not abrupt or violent. It is steady, continuous, always present. Another calming truth is the way Jupiter interacts with its moons. Each of the Galilean moons, Io, Europa, Ganymede, and Callisto, orbits in a delicate gravitational relationship known as orbital resonance. For every orbit Ganymede completes, Europa completes 2 and Io completes 4. This rhythmic pattern keeps their orbits stable, preventing chaotic interactions. A quiet harmony maintained by gravity. This resonance also creates internal heating within some of the moons. As their orbits are slightly stretched and compressed, tidal forces generate heat inside them. On Io, this leads to intense volcanic activity, lava flowing across its surface in continuous motion. On Europa, this heating may keep a vast ocean of liquid water beneath its icy crust. These processes are not violent, but persistent. They continue quietly, shaping these moons over time. Another soothing truth is Jupiter's role in maintaining the structure of the solar system. Its gravity has helped clear out debris in certain regions, influencing where other planets could form. It may have prevented the formation of another large planet in the asteroid belt, leaving behind the scattered rocks we see today. In this way, Jupiter is not just a participant in the solar system. It is a defining presence. Another fascinating detail is the way light interacts with Jupiter's clouds. Sunlight, though weaker at Jupiter's distance, still illuminates the planet's atmosphere. The clouds reflect and absorb this light in different ways, creating subtle variations in color: creams, browns, reds, and hints of orange. These colors shift gently over time as storms evolve and cloud patterns change. Nothing sudden, just gradual transformation. Another calm truth is that Jupiter's storms, while massive, are not chaotic in the long term. They follow patterns influenced by rotation, heat, and atmospheric dynamics. The Great Red Spot, though slowly shrinking, has persisted for centuries, its motion steady and predictable. Even smaller storms merge, separate, and fade in ways that maintain an overall balance. It is a system of motion without disorder. Another gentle realization is that Jupiter, like all planets, is in motion through the galaxy. While it orbits the Sun every 12 Earth years, the entire solar system is also moving around the center of the Milky Way. Jupiter, along with everything else, is part of this larger journey. And yet, none of this motion feels hurried. It unfolds over timescales so vast that it becomes almost still. Another fascinating aspect is the sound that Jupiter might produce. Though space itself is silent, the interactions within Jupiter's magnetosphere can generate radio waves, signals that can be detected by instruments. These emissions, when converted into sound, create eerie, low-frequency tones. Not noise, but a kind of distant hum. A reminder that even in silence, there is activity. Another calming truth is the sheer scale of Jupiter's presence. If you imagine placing Earth next to Jupiter, it would appear small, almost fragile. And yet, both worlds exist in the same system, both following the same fundamental laws of physics. Size does not disrupt harmony. Everything moves together, regardless of scale. Around it, moons orbit in quiet rhythm, each following its path, each influenced by the giant at the center. Beyond them, faint rings drift, barely visible, yet still part of the whole. All of it moving together in perfect balance. And perhaps that is the most peaceful truth of Jupiter. Even the largest forces in the solar system, even the most powerful gravity, can exist in calm, steady harmony. Nothing rushes. Nothing breaks the rhythm. Everything simply continues, as it always has. Chapter 7: Saturn and its rings of ice. There's a quiet elegance to Saturn. Among all the worlds that orbit the Sun, Saturn stands apart. Not because it is the largest nor the most powerful, but because of its delicate beauty. Its rings, thin and luminous, stretch outward like soft lines drawn across the darkness, forming one of the most serene sights in the solar system. And yet, beneath that beauty lies a story of motion, structure, and quiet balance. Saturn, like Jupiter, is a gas giant, composed mostly of hydrogen and helium. But it is less dense than Jupiter, and in fact, less dense than water. If you could place Saturn in an unimaginably large ocean, it would float. This is not because it is small. It is enormous, capable of holding more than 760 Earths within its volume. But because its material is spread out, light gently compressed. Another calming truth is Saturn's rotation. It spins rapidly, completing one rotation in about 10.7 hours. This fast rotation causes the planet to flatten slightly at the poles and bulge at the equator, creating a shape that feels subtly stretched. But like Jupiter, Saturn's atmosphere is not chaotic. Its clouds form bands, soft layers of color that blend into one another. These bands are less vivid than Jupiter's, giving Saturn a more muted, golden appearance. A softer world in tone and texture. Perhaps the most mesmerizing feature of Saturn is its ring system. At first glance, the rings appear solid, like a continuous disk encircling the planet. But in reality, they are made of countless individual particles, ranging from tiny grains of ice to chunks as large as houses. Each piece orbits Saturn independently, following its own path, yet together they form a structure of incredible coherence, a system of many behaving as one. The rings are composed mostly of water ice, which reflects sunlight efficiently. This is why they appear so bright, so luminous, even from great distances. And yet, despite their vast width, spanning hundreds of thousands of kilometers, the rings are incredibly thin. In many places, they are only about 10 meters thick. A vast structure, delicate and almost fragile. Another gentle truth is that the rings are not uniform. They are divided into distinct sections, separated by gaps. One of the most prominent is the Cassini division, a dark region that appears as a break between the main rings. These gaps are not empty. They are shaped by the gravitational influence of Saturn's moons, which create patterns and waves within the ring system. Small moons, known as shepherd moons, orbit near the edges of rings, guiding particles, keeping them confined. A quiet guidance maintaining order. Another fascinating aspect is the constant motion within the rings. Each particle moves at a different surrogate depending on its distance from Saturn. Inner particles orbit faster, outer ones more slowly. This creates subtle interactions, collisions that are gentle rather than violent. Over time, these interactions smooth out irregularities, maintaining the overall structure. Nothing chaotic, just continuous adjustment. Another soothing truth is that Saturn's rings are not permanent. They are relatively young, possibly forming only a few 100 million years ago. Scientists believe they may have originated from the remnants of a moon or comet that was torn apart by Saturn's gravity. And slowly, over time, the rings are fading. Particles are gradually being pulled into the planet or drifting away. This means that the rings we see today are temporary, existing within a specific window of time, a brief moment in cosmic terms. And yet, for us, they feel eternal. Another calming detail is the way light interacts with the rings. As sunlight passes through them, it creates soft shadows on Saturn's surface. These shadows shift slowly as the planet moves in its orbit, creating subtle changes in appearance over time. At certain angles, the rings seem to disappear entirely, becoming almost invisible when viewed edge on from Earth. A structure so vast, yet capable of vanishing from sight. Another fascinating truth is Saturn's internal heat. Like Jupiter, Saturn emits more energy than it receives from the Sun. This heat comes from gravitational compression and the slow settling of helium within its interior. As helium droplets sink toward the core, they release energy, contributing to the planet's warmth. A quiet process unfolding deep within. Another gentle realization is the presence of Saturn's magnetic field. Though not as strong as Jupiter's, it still extends far into space, creating a magnetosphere that interacts with the solar wind. This interaction produces auroras near Saturn's poles, soft glows of light that shimmer in the darkness. A silent display, far from the Sun. And then there are Saturn's moons. Among them is Titan, a world with a thick atmosphere and lakes of liquid methane. Titan is unique in the solar system, a place where chemistry unfolds in ways both familiar and strange. There is also Enceladus, a small moon that reflects sunlight brilliantly and ejects plumes of water vapor into space, evidence of a hidden ocean beneath its icy surface. These moons add depth to Saturn's quiet majesty. They orbit in harmony, interacting subtly with the rings and with each other. Another calming truth is the way Saturn moves through space. It takes about 29 Earth years to complete one orbit around the Sun. This slow journey gives Saturn a sense of patience, a long, steady rhythm that contrasts with the quicker motion of inner planets. Everything about Saturn feels unhurried. And as you imagine it now, let the image settle gently in your mind. A Vishal golden sphere surrounded by luminous rings drifting through the darkness. Particles of ice moving in silent orbits, forming patterns that remain stable over time. Moons circling quietly, each following its path. Light reflecting softly, shadows shifting slowly. A world defined not by intensity, but by elegance. As Saturn continues its slow orbit around the Sun, the quiet elegance of its rings begins to reveal even deeper layers of structure and a subtle motion. What appears from a distance as a single, continuous band of light is, in truth, a finely detailed system, composed of thousands of smaller ringlets, each with its own delicate pattern. These ringlets are shaped by gravity, by motion, and by the quiet influence of Saturn's many moons. Within the rings, nothing is still. Every particle, whether a grain of ice or a larger fragment, moves along its own path, orbiting Saturn with precise timing. The closer a particle is to the planet, the faster it travels. Farther out, the gati slows, creating a gentle gradient of motion. And yet, despite these differences, the rings maintain their form. It is a balance achieved through countless tiny interactions. Particles collide, softly absorbing and redistributing energy. Over time, these collisions smooth out irregularities, keeping the rings thin and organized. There is no single force controlling them. only the collective behavior of many small parts. A quiet harmony emerging from simplicity. Another fascinating truth is the presence of waves within the rings. These are not waves in the sense of water, but patterns created by gravitational interactions. As moons orbit Saturn, their gravity subtly pulls on ring particles, creating ripples, spiral patterns that move through the rings like echoes. These waves can stretch across vast distances, yet they remain invisible to the eye without close observation. A hidden motion beneath the stillness. Some moons, known as shepherd moons, play a particularly important role. They orbit near the edges of rings, guiding particles, preventing them from drifting away. Through their gravitational influence, they maintain sharp boundaries between different ring sections. Without them, the rings might slowly spread out, losing their distinct structure. Instead, they remain defined, contained, stable. Another gentle truth is the changing angle of Saturn's rings. As Saturn orbits the Sun over its 29-year cycle, the angle at which we see the rings from Earth changes. Sometimes they are wide open, revealing their full structure. At other times, they tilt until they appear almost edge-on, becoming thin lines that nearly disappear. This shifting perspective reminds us that even the most constant features can appear to change, depending on how we observe them. A quiet transformation without any real change at all. Another calming detail is the temperature of the rings. Despite their brightness, they are incredibly cold, often around -180 degrees Celsius. The particles reflect much of the sunlight that reaches them, absorbing only a small amount of heat. And yet, even in this cold, they move, orbiting, colliding, adjusting in a slow and continuous flow. Another fascinating aspect is the subtle color variation within the rings. While they appear mostly white or pale gold, closer observation reveals hints of variation, slight differences caused by impurities in the ice or by the effects of space weathering over time. These variations are gentle, almost imperceptible, but they add depth to the ring's appearance. Rain falls, rivers flow, landscapes change, all in quiet, chemical balance. Then there is Enceladus, small and bright. Enceladus reflects nearly all the sunlight that reaches it. Beneath its icy surface lies a hidden ocean, and from cracks near its south pole, jets of water vapor and ice particles are ejected into space. These plumes rise gently, feeding material into Saturn's rings, connecting moon and planet in a continuous exchange. A quiet cycle linking worlds together. Another soothing truth is that Saturn's system is not static. Over long periods, the orbits of its moons shift slightly. The rings evolve, particles are lost or gained. But these changes happen slowly, far beyond the pace of human perception. What we see now feels constant, a snapshot of balance within an ongoing process. Another fascinating detail is Saturn's internal structure. Like Jupiter, it likely contains layers of hydrogen, gaseous on the outside, metallic deeper within. At its core, there may be a dense region of heavier elements, compressed under immense pressure. Heat from within continues to rise, shaping the atmosphere, contributing to the gentle patterns we observe. Even in a world so distant, energy flows. Another calming realization is the silence of Saturn. There are no sounds in the traditional sense. No winds you can hear, no storms you can feel. The movement of its atmosphere, the motion of its rings, all occur in complete silence. And yet, through instruments, we can detect subtle vibrations, radio emissions from its magnetosphere, faint signals that can be translated into sound, a distant hum echoing through space. Another gentle truth is the scale of Saturn's presence. If Earth were placed within its rings, those rings would stretch far beyond the distance to the moon. And yet, despite their size, they remain thin, delicate, almost fragile. A contrast that feels almost poetic. Immense yet light, vast yet subtle. And as you drift deeper into relaxation, imagine Saturn once more. The golden glow of its atmosphere, soft and layered. The rings, luminous and thin, stretching outward in perfect alignment. Particles moving in silent orbits, guided by gravity, shaped by time. Moons circling quietly, each part of a larger system, each contributing to the balance. Nothing rushed, nothing forced, everything moving exactly as it should. And perhaps that is the most peaceful truth of Saturn. Even the most intricate systems, even structures of immense beauty, can exist in quiet harmony. A harmony that does not demand attention, but gently invites it. These are the ice giants, worlds colder, darker, and more mysterious than anything closer to the sun. And yet, despite their distance, despite the faint sunlight that reaches them, they are not empty or inactive. They are calm, but alive with subtle motion. Let us begin with Uranus. At first glance, Uranus appears almost featureless, a soft, pale blue sphere suspended in darkness. Its color comes from methane in its atmosphere, which absorbs red light and reflects blue. But what makes Uranus truly unique is not its color, but its orientation. Uranus is tilted on its side. Its axis is inclined by about 98 degrees, meaning it essentially rolls around the sun rather than spinning upright like other planets. This creates a very different experience of time and light. At its poles, there are long periods, lasting decades, of continuous sunlight, followed by decades of darkness. A slow, quiet cycle stretching across generations. Another calming truth is the length of Uranus's year. It takes about 84 Earth years to complete a single orbit around the Sun. This means that each season on Uranus lasts more than 20 Earth years. Imagine a sunrise that lingers, a winter that stretches gently across decades. Time moves differently here, more slowly. These moons are cold, distant worlds, orbiting in the same tilted plane as Uranus itself. They share in the planet's unusual orientation, moving through long periods of light and darkness. Now let your thoughts drift farther outward to Neptune. If Uranus is calm and subdued, Neptune is deeper, richer, a darker shade of blue that hints at greater activity beneath the surface. Neptune is the farthest known planet from the Sun, receiving only a small fraction of the sunlight that reaches Earth. And yet, despite this distance, Neptune is not still. It is home to the fastest winds in the solar system. These winds can reach speeds of over 2,000 kilometers per hour, moving clouds across the planet in sweeping patterns. Storm systems form and fade, including large features like the Great Dark Spot, a massive storm observed by spacecraft. And yet, even with these powerful winds, there's a sense of rhythm. The storms evolve slowly, the winds follow patterns, and the overall system remains balanced. Another fascinating truth is Neptune's internal heat. Like Jupiter and Saturn, Neptune emits more energy than it receives from the Sun. This internal heat drives its atmospheric activity, powering the winds and storms that define the planet. A quiet energy rising from within. Another calming detail is Neptune's orbit. It takes about 165 Earth years to complete one journey around the Sun. This means that since its discovery in 1846, Neptune has only completed one full orbit. A slow, deliberate path, far from the inner worlds. Neptune also has a faint ring system, though it is even more subtle than Uranus's. These rings contain clumps of material, arcs that are not evenly distributed, a structure that feels incomplete, yet stable. And like Uranus, Neptune has its own collection of moons. The largest is Triton. Triton is unique. It orbits Neptune in the opposite direction of the planet's rotation, suggesting that it was captured rather than formed in place. Its surface is cold and icy, yet it shows signs of activity, including geysers that release nitrogen gas into the thin atmosphere. Even in the coldest regions, there is motion. Another soothing truth is the color of these distant worlds. The blue tones of Uranus and Neptune come from methane absorbing red light, leaving blue wavelengths to dominate. But Neptune's deeper color suggests additional processes, perhaps the presence of other compounds or atmospheric dynamics that enhance the hue. A subtle difference creating distinct identities. And as you imagine these two planets together, drifting far from the Sun, you see Uranus, pale and tilted, moving quietly through long seasons, and Neptune, deep blue and dynamic, its winds shaping patterns across the atmosphere. Both distant, both cold, both moving in silence. As Uranus and Neptune continue their distant journey around the Sun, their quiet presence reveals a deeper kind of beauty, one that does not rely on brightness or closeness, but on stillness, distance, and time. Out here, sunlight is faint. At Neptune's orbit, the Sun appears as a bright star rather than a dominating disk. The light that reaches these planets is soft, diluted by distance, and yet, it is enough to illuminate their atmospheres and reveal their subtle colors. A gentle glow, carried across billions of kilometers. Another calming truth is the temperature of these worlds. They are among the coldest places in the solar system. Temperatures in the upper atmospheres of Uranus and Neptune can drop below minus 200 degrees Celsius. And yet, despite this cold, both planets maintain dynamic internal processes. It is a reminder that warmth does not always come from the outside. Sometimes it rises from within. Let us return again to Uranus. One of the most unusual truths about Uranus is the quiet stillness of its atmosphere, at least from a distance. For many years, it appeared almost featureless, leading to the impression that it was a calm and inactive world. But closer observations have revealed subtle cloud formations, faint storms, and seasonal changes that unfold over decades. Because of its extreme tilt, Uranus experiences sunlight in a way no other planet does. For long periods, one hemisphere faces the Sun continuously, while the other remains in darkness. This creates slow shifts in temperature and atmospheric behavior, changes that occur so gradually they can only be observed over many years. A planet that lives in slow motion. Another gentle truth is the nature of Uranus's interior. Beneath its atmosphere lies a thick mantle of icy materials, water, ammonia, and methane in a superheated fluid state. These substances exist under such pressure that they behave in ways unlike anything we experience on Earth. Some scientists even suggest that deep within Uranus, conditions may allow for the formation of diamonds, carbon compressed into solid crystals, drifting slowly through the planet's interior. A quiet transformation hidden far below. Uranus also has a magnetic field, but unlike Earth's, it is tilted and offset from the planet's center. This creates a magnetosphere that is uneven, shifting, and somewhat unpredictable in shape. And yet, even this irregularity follows patterns. It changes with the planet's rotation, interacting with the solar wind in subtle ways. Another calming detail is the faintness of Uranus's rings. They are dark, narrow, and composed of relatively large particles. Unlike Saturn's bright rings, Uranus's rings absorb more light than they reflect, making them difficult to see. They're there, quietly circling, but often hidden from view. Now, let your thoughts drift again toward Neptune. If Uranus is subtle, Neptune is quietly active. Neptune shows more visible weather patterns, clouds that shift, storms that form and fade, winds that move faster than anywhere else in the solar system. And yet, despite these powerful winds, the planet does not feel chaotic. The motion is smooth, continuous, part of a larger balance. Another fascinating truth is the way Neptune's storms evolve. The Great Dark Spot, observed by the Voyager 2 spacecraft, was a massive storm similar in some ways to Jupiter's Great Red Spot. But unlike Jupiter's long-lived storm, Neptune's features can appear and disappear over time. Storms form, drift, and fade, a cycle of creation and dissolution. Another gentle truth is the role of internal heat. Neptune radiates more than twice the energy it receives from the sun. This internal energy drives convection, warm material rising, cool material sinking, creating the dynamic atmosphere we observe. Even in the coldest reaches, there is movement. Another calming detail is Neptune's moon, Triton. Triton orbits in a retrograde direction, meaning it moves opposite to Neptune's rotation. This suggests it was captured, perhaps once a wandering object from the outer solar system. Its surface is smooth and icy, with few impact craters, indicating that it has been resurfaced over time. And then there are its geysers. Dark plumes of nitrogen gas rise from Triton's surface, drifting upward before falling back down. These geysers are powered by the weak sunlight that reaches the moon, warming subsurface layers just enough to release trapped gas. A delicate process sustained by faint energy. Another soothing truth is the scale of distance. The gap between Uranus and Neptune is vast, and beyond Neptune, the distances grow even greater. Objects in these outer regions move slowly, taking hundreds or thousands of years to complete an orbit. Time stretches outward, becoming less urgent, more expansive. Another fascinating aspect is how little we have explored these distant planets. Only one spacecraft, Voyager 2, has visited Uranus and Neptune directly. It passed by them decades ago, sending back images and data that continue to shape our understanding. Since then, these worlds have remained largely untouched, observed only from afar. They exist in quiet isolation, far from the constant attention given to nearer planets. And perhaps that is part of their calm. They are distant, not only in space, but in experience. Another gentle realization is that Uranus and Neptune represent a different kind of planetary existence. They're not rocky like Earth, not gas giants like Jupiter and Saturn in the same way, but something in between. Worlds of ice, fluid interiors, and subtle motion. They expand our understanding of what a planet can be. And as you settle deeper into stillness, imagine these two distant giants. Uranus, tilted and pale, drifting through long seasons, its atmosphere calm and understated. Neptune, deep blue and dynamic. Winds shaping clouds, storms forming and fading in quiet cycles. Both moving slowly, far from the sun, far from the inner worlds. No rus, no noise, only distance and time and gentle motion. And perhaps that is the most peaceful truth of the ice giants. Even at the far edges of the solar system, where light is faint and temperatures are low, there is still movement, still balance, still a quiet rhythm that continues without interruption. Chapter 9. Asteroids, comets, and forgotten worlds. Between the larger planets and far beyond them, there exists a quieter population of objects. Not world in the traditional sense, not vast or dominant, but countless smaller bodies drifting gently through space. These are the remnants of formation, the pieces that never became planets, the fragments that still carry the earliest memories of the solar system. They move without urgency, following paths shaped long ago, orbiting the sun in silent, predictable patterns. Let us begin with asteroids. Most asteroids are found in a region known as the asteroid belt, located between Mars and Jupiter. This region contains millions of rocky bodies, some no larger than dust grains, others hundreds of kilometers across. And yet, despite their number, the asteroid belt is not crowded. The distances between individual asteroids are vast. If you were to travel through it, you would likely see very little. Just occasional rocks drifting quietly against the backdrop of space. A region of many objects, yet filled with emptiness. Another calming truth is that asteroids are incredibly diverse. Some are composed mostly of rock, others of metal, and some contain a mixture of both. Their surfaces are often irregular, shaped by impacts and gravitational interactions over billions of years. They do not form perfect spheres. They remain as they are shaped by their history. One of the most fascinating objects in the asteroid belt is Ceres. Ceres is large enough to be classified as a dwarf planet. It has a roughly spherical shape and even contains water ice beneath its surface. Bright spots observed on Ceres are thought to be deposits of salts, left behind as water evaporated long ago. A quiet world, holding traces of water, far from the sun. Another intriguing asteroid is Vesta. Vesta has a differentiated structure, meaning it has layers, core, mantle, and crust, similar to a planet. Its surface shows evidence of ancient volcanic activity and massive impacts. It is a reminder that even small bodies can have complex histories. Another gentle truth is that some asteroids leave the belt. Gravitational interactions, especially with Jupiter, can alter their paths, sending them into new orbits. Some become near-Earth objects, occasionally passing close to our planet. But these movements are not sudden. They unfold over long periods guided by gravity. Another fascinating group of objects are comets. Unlike asteroids, comets are composed largely of ice and dust. They originate from distant regions of the solar system, where temperatures are low enough for volatile materials to remain frozen. When a comet travels closer to the sun, something beautiful happens. The heat causes its ice to sublimate, turning directly from solid to gas. This process releases dust and gas into space, forming a glowing coma around the comet's nucleus. And then, the tail appears. The tail of a comet is not a trail left behind, but a stream of material pushed away by solar radiation and the solar wind. It always points away from the sun, regardless of the comet's direction of travel. A gentle alignment shaped by light itself. One of the most well-known comets is Halley's Comet. It returns to the inner solar system approximately every 76 years, tracing a long, elliptical orbit. Each time it appears, it carries with it the same material, the same structure, unchanged except for the slow loss of its outer layers. A visitor that returns again and again. Another calming truth is that comets are fragile. With each pass near the sun, they lose a small amount of material. Over time, they may break apart or become inactive, leaving behind rocky remnants that resemble asteroids, a gradual fading rather than a sudden end. Another fascinating region is the Kuiper Belt. Located beyond Neptune, this region contains countless icy objects, remnants from the outer solar system's formation. Among them are dwarf planets like Pluto. These objects move slowly, taking hundreds of years to complete an orbit. Time stretches outward, becoming less immediate, more expansive. Another gentle truth is the existence of the Oort cloud. Far beyond the Kuiper Belt, this distant region forms a vishal spherical shell around the solar system. It is thought to be the source of long-period comets, objects that take thousands or even millions of years to return. The Oort cloud is so distant that its outer edges may lie nearly halfway to the nearest star. And yet, even these objects remain loosely bound to the sun, gravity extending its influence across unimaginable distances. Another calming realization is that these smaller bodies are not separate from the rest of the solar system. They are part of its history, its foundation, its memory. Each asteroid, each comet, each distant icy object carries information about the conditions that existed billions of years ago. They are not incomplete planets. They are preserved beginnings. Another fascinating detail is the way light interacts with these objects. Asteroids reflect sunlight differently depending on their composition, some appearing bright, others dark. Comets glow as they release gas and dust, creating soft, luminous shapes that change over time. Even in darkness, there is visibility. Another gentle truth is that these objects move in predictable orbits. Though their paths may seem complex, they follow the same gravitational rules as planets. Their motion is steady, calculable, part of the larger system. Nothing random, everything connected. And as you imagine these smaller worlds drifting through space, you see asteroids scattered across the belt, silent and still. Comets traveling long paths, their tails glowing softly as they approach the sun. Distant objects in the Kuiper Belt moving slowly in the cold. All of them part of the same quiet system. As the smaller bodies of the solar system continue their quiet journeys, a deeper truth begins to emerge. These objects are not simply leftovers, they are storytellers. Each asteroid, each comet, each distant fragment carries within it a record of time, unchanged, unaltered, and preserved across billions of years. While planets evolve and reshape themselves, these smaller worlds remain as they were, offering glimpses into the earliest moments after the sun first began to shine. And in their stillness, there is clarity. Let us return again to the asteroids. While many remain in the belt between Mars and Jupiter, others travel along paths that bring them closer to the inner solar system. These are known as near-Earth asteroids. Their orbits are not chaotic. They are shaped by gravitational interactions, subtle nudges over long periods that gently alter their wusser. Some pass Earth at safe distances, others cross its orbital path, but remain predictable in their motion. A quiet crossing without disruption. Another gentle truth is that asteroids sometimes interact with one another. When two asteroids collide, the event is not explosive in the way we might imagine. At such small scales and low gravity, collisions can be slow, even soft. Material may break apart, fragments drifting away to form new shapes. Over time, these fragments can reassemble into loosely bound structures known as rubble pile asteroids, collections of pieces held together by gravity rather than solid cohesion. A world made of many parts, loosely connected, yet stable. Another fascinating detail is the presence of Trojan asteroids. These are groups of asteroids that share an orbit with a planet, clustering around stable points ahead of and behind it. Jupiter hosts the largest population of these Trojans, with thousands of objects moving in harmony along its path. They do not collide with the planet. They follow it like quiet companions maintaining a steady distance. A shared journey without interference. Now, let your thoughts drift toward comets once more. When a comet approaches the inner solar system, its transformation is gradual. The warmth of the sun causes its surface to release gas and dust, forming the coma and tail. But this process is uneven. Jets of material can erupt from specific monarchica on the comet's surface, creating patterns that shift as the comet rotates. These jets are not violent. They are gentle releases controlled by heat and structure. A slow awakening as the comet nears the sun. One of the most detailed observations of a comet came from the Rosetta mission, which studied Comet 67P/Churyumov-Gerasimenko. The mission revealed a surface shaped like a rubber duck, with cliffs, plains, and active monarchica where gas was escaping. It showed that comets are not simple icy balls, but complex worlds with their own features and behaviors. And yet, even in their activity, they remain quiet. Another soothing truth is that comets contribute to the solar system in subtle ways. As they travel, they leave behind trails of dust. When Earth passes through one of these trails, the particles enter our atmosphere and burn up, creating meteor showers. These showers, like the Perseids or Leonids, appear as streaks of light across the night sky. Brief, gentle, and beautiful. Each streak is a tiny fragment, a piece of a comet, returning to visibility for just a moment. Another fascinating region is the Kuiper Belt, where objects like Pluto reside. Pluto, once considered the 9th planet, is now classified as a dwarf planet. But this change does not diminish its significance. It is a complex world with mountains of ice, a thin atmosphere, and a surface that shows signs of change. It moves slowly, taking 248 Earth years to complete one orbit around the sun, a long, quiet journey through the outer reaches. Another gentle truth is that Pluto is not alone. Other dwarf planets, like Eris Haumea and Makemake also inhabit these distant regions. Each has its own characteristics, its own orbit, its own quiet story. Together, they form a population of worlds that expand our understanding of what exists beyond the traditional planets. And beyond even these lies the Oort cloud. Though never directly observed, it is believed to be a Vishal reservoir of icy bodies extending far beyond the Kuiper belt. Objects from this region can be perturbed by passing stars or gravitational interactions, sending them inward as long-period comets. These comets take thousands, sometimes millions of years to return. Time, here, becomes almost immeasurable. Another calming realization is that these distant objects are not isolated. They are connected through gravity, through origin, through motion. Even the farthest comet, drifting at the edge of the solar system, remains linked to the sun, a connection that does not break. Another fascinating detail is the way these objects reflect light. Some are dark, absorbing most of the sunlight that reaches them. Others are brighter, their icy surfaces reflecting light more efficiently. These differences create subtle variations in appearance, hints at their composition. A quiet diversity across countless objects. Another gentle truth is that these smaller worlds remind us of scale. The solar system is not just planets and moons. It is filled with countless fragments, each following its own path. Together, they create a system that is both structured and expansive. Nothing is wasted. Nothing is unnecessary. Everything has its place. And as you let your mind drift, imagine this vast collection. Asteroids scattered yet ordered, moving silently between planets. Comets traveling long arcs, glowing softly as they approach the sun. Dwarf planets, distant and slow, holding onto their icy surfaces. And beyond them, the faint, unseen presence of the Oort cloud, extending outward into the darkness. All of it part of the same system, all of it moving gently, endlessly. And perhaps that is the most peaceful truth of these forgotten worlds. They are not forgotten at all. They are simply quiet. Chapter 10, the edge of the solar system and beyond, at some point far beyond the distant orbit of Neptune. The solar system begins to fade. Not suddenly, not with a clear boundary, but gradually, softly, like light dimming at the end of a long day. Here, the influence of the sun becomes weaker. The warmth that once shaped planets and guided motion is now faint, stretched thin across unimaginable distances. And yet, even here, the solar system continues. One of the most important truths about the edge of the solar system is this. There's no sharp line where it ends. Instead, there is a region known as the heliosphere, a vishal bubble created by the solar wind. This wind, made of charged particles, flows outward from the sun in all directions, carrying its influence far into space. For billions of kilometers, this invisible flow continues until it meets the interstellar medium, the thin gas and dust that exists between stars. Where these two meet, the solar wind slows down. This boundary is called the termination shock. It is not a wall, not a barrier, but a gradual change. The particles slow, the pressure shifts, and the environment becomes different. Farther out still lies the heliopause. This is the region where the influence of the sun is balanced by the pressure of interstellar space. Beyond this point, the solar wind can no longer push outward effectively. And so, the solar system gently gives way to the galaxy. Another calming truth is that this transition is incredibly quiet. There are no sudden changes, no dramatic events, only gradual shifts in energy and density. Space remains dark, silent, and vast. And yet, something remarkable has reached this distance. Human-made objects. The Voyager 1 and Voyager 2 spacecraft have traveled farther than any other objects created by humanity. Launched in 1977, they have spent decades moving outward, slowly crossing the boundary of the heliosphere. Voyager 1 has already entered interstellar space. It continues to send back faint signals, carrying information across billions of kilometers. A quiet message from the edge of our system. Another gentle truth is the scale of distance at this boundary. Light itself, moving at 300,000 kilometers per second, takes many hours to travel from the Sun to these distant regions. For Voyager, communication with Earth involves delays of over 20 hours one way. Time stretches, distance deepens. Everything becomes slower, softer, more distant. Beyond the heliopause lies interstellar space. This is not empty. It contains gas, dust, and faint radiation, but it is far less dense than anything within the solar system. It is the space between stars, a vast ocean through which entire systems drift. And within this ocean, our solar system is just one of many. Another fascinating truth is that the solar system itself is moving. While planets orbit the Sun, and the Sun anchors the system, the entire solar system is traveling through the Milky Way galaxy. It orbits the galactic center, completing one full rotation in about 225 million years. This means that everything, every planet, every comet, every distant object, is moving together through the galaxy. A shared journey across immense distances. Another calming realization is that even at the edge, gravity still connects everything. The Sun's gravitational influence extends far beyond the heliosphere. Objects in the distant Oort cloud, those faint icy bodies at the edge, are still bound to the Sun, even though they are incredibly far away. The connection weakens, but it does not break. Another gentle truth is the darkness of this region. Without nearby planets or strong sunlight, the outer solar system is dim. Stars appear sharper, more numerous, filling the sky with distant light. There are no bright horizons, no nearby glow, only the quiet presence of distant stars. And yet, this darkness is not empty. It is full of motion, full of structure, full of connection. Another fascinating detail is the future of these distant regions. Over billions of years, gravitational interactions with passing stars may gently disturb objects in the outer solar system. Some may be pulled away, drifting into interstellar space. Others may be sent inward, becoming long-period comets. Nothing sudden, only slow change. Another calming truth is that the solar system will continue long after us. The Sun will keep shining for billions of years. The planets will continue their orbits. The distant objects will remain, drifting quietly at the edges. Time here is vast, unhurried, endless. And as you imagine this boundary, this quiet edge, you see the Sun, far away now, just another bright star among many. You see the faint path of Voyager, moving outward, carrying a small record of humanity into the darkness. You see the vastness beyond, stretching endlessly, filled with stars that are themselves distant suns. And within it all, the solar system remains. A small, steady system moving through a much larger universe. Not isolated, not alone, just one part of something greater. As we drift farther beyond the familiar paths of the planets, beyond even the distant pull of Neptune, the solar system begins to feel less like a place and more like a quiet presence. Not defined by borders, not contained by edges, but slowly blending into something much larger. Out here, the light from the sun is no longer dominant. It fades into the background, becoming just one among countless other stars scattered across the galaxy. And yet, even as its brightness diminishes, its influence continues. Gravity still reaches outward, gently, persistently, holding onto the most distant objects that remain part of its domain. One of the most profound truths about this region is that it represents a transition, not an ending. The solar system does not stop. It simply becomes less dense, less defined, until it is indistinguishable from the surrounding galaxy. The Oort cloud, that vast and distant collection of icy bodies, forms the outermost whisper of our system. Objects here are separated by enormous distances. They move slowly, taking thousands, even millions of years to complete a single orbit around the sun. Time becomes almost abstract. Motion becomes almost still. Another gentle truth is that beyond this region, other stars exist in similar quiet systems. Each star you see in the night sky may have its own collection of planets, asteroids, and comets, its own version of a solar system. Some may be larger, some smaller, some more complex, but all shaped by the same universal forces: gravity, time, motion. And yet, the distances between these stars are vast beyond easy understanding. The nearest star system lies over 4 light years away. That means even light, moving at the fastest speed possible, takes more than 4 years to travel from there to here. And so, the space between stars is not just empty, it is expansive, deep, calm. Another fascinating detail is the journey of the Voyager 1 spacecraft. Attached to it is a golden record, a small, carefully prepared collection of sounds and images from Earth. It carries music, greetings in many languages, and recordings of natural sounds: wind, water, footsteps. A quiet message sent into the unknown. It does not expect a reply. It simply exists, traveling outward, slowly, endlessly. Perhaps, one day, it may pass near another star. Or perhaps it will continue drifting alone for billions of years. Another calming truth is that nothing in space truly stands still. Even in the deepest darkness, everything is in motion. Stars orbit the center of the galaxy. Galaxies move relative to one another. And the universe itself is expanding, slowly increasing the distance between distant objects. And yet, none of this feels rushed. All of it unfolds over timescales so vast that motion becomes almost indistinguishable from stillness. Another gentle realization is that the solar system is both small and complete. Small in the sense that it is just one of many systems in the Milky Way, but complete in the sense that everything within it, from the smallest asteroid to the largest planet, exists in balance. Nothing is out of place. Nothing is unnecessary. Everything follows its path. Another soothing truth is the continuity of this system. Even as objects drift outward, even as distances grow, the connections remain. Gravity though it weakens with distance, never fully disappears. The sun still holds on to its farthest companions, and those companions continue their slow orbits, even at the very edge. Another fascinating thought is that the atoms within you, the matter that makes up your body, once existed in ancient stars. Long before the solar system formed, before the sun ignited, these atoms were created in the cores of other stars and scattered into space through supernova explosions. Over time, they became part of the cloud that formed our solar system, and eventually part of you, a quiet connection between you and the universe. Another calming truth is that the universe does not demand anything. It does not rush. It does not force. It simply allows processes to unfold slowly, naturally, over time. Stars form, planets emerge, systems stabilize, and everything continues in gentle motion. As you rest deeper now, imagine the solar system from a great distance. The sun, a small point of light. The planets invisible at this scale. The outer regions fading into darkness. And beyond that, the vast expanse of the galaxy, filled with countless other stars. Each one with its own story. Each one part of something even larger. And within all of this, there's a quiet sense of peace. Because nothing here is chaotic. Nothing is truly out of balance. Everything follows a rhythm, a pattern, a steady flow that continues without interruption. And perhaps that is the final truth of the solar system. It is not just a collection of planets and objects. It is a system of harmony, a place where motion and stillness exist together, where time stretches gently, where everything moves, but nothing feels rushed. And as you drift into rest, you can carry that feeling with you. That quiet, steady rhythm, that sense of calm motion, that understanding that even in a vast and complex universe, everything continues exactly as it should.